everyone, and welcome to a new episode of Soil Talks, the podcast where we explore how science, innovation, and local communities work together to improve soil health. I'm Andrés Rodríguez Seijo, coordinator of InBestSoil, a European project that brings together researchers, farmers, foresters, and a wide community of stakeholders with a common goal: protecting and enhancing soil health. Our mission is to demonstrate that a healthy soil is not just an ecological asset. It is the engine of the profitable and resilient business models. After learning about regenerative agriculture in Netherlands, we return to Spain, with this time heading to the northwest Spain, to the Atlantic region. And today we land in Galicia, a land of green landscape that has benefits in surface the markers for intense industrial activity. Today we are going to discover how a former copper mine was resembling an acidic desert have been transforming in a thriving ecosystem full of life. Joining us is Javier de Rivera from the University of Vigo, who, together with the Centro de Valorización Ambiental del Norte, the band that is also partnering in InBestSoil, leads this Lighthouse project in the municipality of Touro. Javier is a sociologist and SDS scholar who studies the intersection of science, technology, and society. This is unusual for soil health research project, but it also makes sense in that InBestSoil aims to explore the socioeconomic conditions that can incentivize the production of more healthy soils, and particularly in this lighthouse, where we address the development of a new technology for soil remediation and the opportunities that is open. Well, welcome, Javier.
Hi, Andres. Thanks for having me.
Javier, to set the stage, the Touro mine was exploited for copper extraction until 40 years ago. What were the main environmental issues and the state of the soil when restoration work began?
Well, the problem that after the mining activity was finished in the 80s, at the end of the 80s, no restoration measures were taken. So the mine was left like that. The rocks from the ground were left exposed in the surface, causing the oxidation of the sulfide minerals in them, which then dissolve into rainwater, leaking to the soil and to the water courses. Along the years, this process of oxidations created a vicious circle, accelerating the acidification of soil and water, causing an important environmental catastrophe in the region. Soil's pH reached values of lower than 3, sorry, and toxic water were leaked into the nearby river, the River Ulla, that reaches the famous Ria of Arousa.
Well, a soil with such a low pH are practically incompatible with life, isn't? What kind of organisms were able to survive there?
Well, so no many because of this leak of acidic waters. Biodiversity was heavily affected in the region and in the nearby areas. But on the other hand, then this is interesting from the scientific point of view. These extreme acidic conditions allow the development of new microorganisms that are called extremophils. And that's why when the restoration was began, some smaller areas of the site were left without restoration in controlled conditions to study these new extremophils, these new organisms, because they are very interesting from biodiversity point of view.
Well, interesting. To revert the situation, the main strategy developed was the creation of Technosols. Could you explain what this mixture of inorganic and organic waste is and how they suitably neutralized the soil acidity?
Well, technosols are soils that are created technologically. That means that they are designed to address the specific needs of a particular soil situation. Felipe Macías from the University of Santiago de Compostela and Ceban were pioneers in the development of these techniques in Touro and in other contaminated areas by mining. And the thing is that what they say is that technosols have to be tailored for each particular soil. That means they have to study the conditions of the soil, the particular needs, and create from other sources, from material sources that we're going to talk about later, like for example rock sawdust, ashes from biomass combustion industries, or sewage sludge, which are mainly waste from other industries. They mix them in a way, also mixed with organic compost, to address, to stop this acidic vicious circle and promote biodiversity in the soil.
Okay. Some of them wastes could be toxic if used alone. How do you find the perfect recipe to turn them into a soil that helps plant grow?
In reality, technically and legally, none of these materials are toxic, are defined as toxic. But what is true is that these are materials that, in a high concentration, they can be harmful to the environment. This is the example this is the case, for example, of farm manure from intensive farming, which we all know that is so much concentration of organic matter that it can create a problem in the environment. But when they are mixed with other components, with other materials, and they are mixed in the right proportion, they can even be beneficial because they give organic matter to the soil. So the key here is to analyze the components and to mix them in the proper in the appropriate proportion.
Wow, interesting. We saw in the video that the wastes that can previously to be mixtured and to be tailored of these Technosols. That is very, very interesting to be there. One of the most interesting parts is the synergy between the waste valorization and soil remediation. How do they transform materials like mushes, wastes, or biomass ashes or sludge into a sustainable alternative to fertilizers?
Well, the process of Technosoils production takes up to a month approximately. But we have to think that the process is much longer because we have to analyze, they have to analyze the conditions of the soil to design the ingredient list, to say it like that. So in the production, in the technical production, the raw materials are mixed and aligned in piles, as you can see in the images. And they have to be mixed several times during that month. They have to repeat the process several times, and throughout all this process, they make analysis of how the mixture is going on, and they test the temperature. This is also very interesting, or at least it was for me, because I wasn't used to these processes. That the piles get these piles of organic matter gets really hot. They get really hot because of the chemical interactions that happen there. And this also is useful and is good because it helps to neutralize some hazardous, some possible hazards like the rest of chemicals or fecal bacteria that can be contained in sewage sludge.
I think that what more remarkable is that they use these wastes from other local industries to create this kind of soil that is a perfect of circular economy, right?
Yes, of course, that's exactly the case because they take materials that are waste from other industries and they make something valuable of it. And that's the whole idea of the circular economy, because it all depends of how materials are distributed, how are they located, and that's a very interesting part of this project too.
In addition to restoring the soil itself, the project also created a relative wetland. Could you describe how this artificial wetland was constructed?
This was one of the first interventions that they did with Technosoils in the mine, and it was crucial because the idea was to filter the hyperacidic runoff waters that carried the sulfuric minerals into the nearby streams and the rivers. And for this, they applied Technosols to along the hills where the rainwater flow, and in the bottom they use a complex, in the bottom of these hills they use a complex combination of 7 types of Technosols to reproduce a wetland, an artificial wetland. And the project was very successful in creating a new ecosystem that was able to first filter the hyperacidic waters and then to allow the establishment of natural life in the area.
Okay. How do the wetland work to clean the water coming out from the mine?
Well, so as I said, the wetland is at the bottom of a valley that gathers the runoff waters from the nearby hills. And these hills, were mainly made of rock rubbish from the mine, and they were in this oxidation process leaking sulfuric minerals. So first they have to cover all these rubbish with technosoils, creating green hills, and then when the runoff water goes through these technosoils, they manage to filter the waters in this new soil. And that's how they fix the minerals, the metals and the minerals into the ground, and the water come out clean, and they end up in this wetland.
Okay. And let's talk about the biological results. After 23 years, we're seeing native plants and even birds of prey returning to Touro. Why is the river of these top predators the best proof that the entire food chain is finally back in balance?
Birds of prey are the top predators in the food chain, in a food chain that begins with insects and that have been developed in the reactive wetland, and they are very important because that means the whole food chain is being restored.
Okay, yeah, a key finding in the sources is the high capacity for carbon retention, with levels exceeding 12% of organic carbon in surface horizons. How does this specific pressure contribute to climate change mitigation and economic valuation of the site?
Technosoils have a wide range of applications and potential benefits. Carbon farming is of course one of the most relevant in terms of the strategies being carried out by the EU for climate change mitigation. Think of it as a technology that allows you to design the specific properties that you want to introduce into the soil. For example, technosoils with Andic properties allow the stabilization of organic matter, which in combination with rock dust increases the soil capacity to fix the carbon dioxide, while biomass production fixes carbon during photosynthesis. This means that in these rich soils, the trees grow much faster, so they are able to absorb more carbon dioxide. And in addition, there is also the CO2 emissions that are saved because of the organic matter from the waste that is being used in the technosoils. That if this waste wasn't treated, wasn't introduced, wasn't mixed to produce the technosoils, they would produce themselves more emissions. So there are a lot of potential properties and benefits, and another one of the most impressive benefits of technosoils is the possibility of creating soils that are good for fire prevention, with fire prevention properties that were designed by Seban, and which can be used for reforestation plants and to protect the soil and the forest from fire.
Mhm. How important do you think that is the collaboration between universities, business, and landowners is to ensuring that this long-term environmental sustainability of these projects?
Well, the collaboration between different partners and different agents is crucial for this process. In this lighthouse, nothing could have been done if it wasn't for the collaboration between the landowner company, which is main activity is the promotion of civil construction projects, and the University of Santiago de Compostela, and particularly the researcher Felipe Macias Vázquez, a pioneering researcher in the Technosoils production area. And however, what is lacking here for the development of this technology is a major involvement from the side of public institutions who are failing to see what is the opportunity here to promote the development of a technosols market that can have an enormous environmental potential.
Would you say that this model could be applied in other mining regions or even in other type of degraded lands?
Of course, in fact, it has been applied in the remediation of several mining areas with very good results, and it can also be applied to the restoration of industrial soils and other degraded soils. And furthermore, it can be used to enhance the soil quality in a general sense, not only to restore areas that are contaminated, but also to create better soils for the production of forest or any other green areas. The only requirement that is needed is to have good science behind the design and the making process, so the expected results can be achieved.
However, these processes are not free of controversies. How have local communities reacted to this transformation of this area?
Well, in Touro, the surrounding population was quite angry about the environment catastrophe caused by the negligent way in which the mine was closed at the end of the 80s. So there is a general distrust again mining activities in general. Some of the population support them, but some of them are very they distrust these projects, and it's understandable that they associate even the technosoils they can be associated with mining in general. So there is a little bit distrust about these technologies by some part of the population. And in addition, there are other inconveniences, like for example the presence of trucks or the odor that is produced by some materials. So these have raised some complaints. But of course, if we take in mind take into account the benefits and how pollution was controlled in the area, how the landscape was improved, which are objective results of the project, the change has to be considered highly positive.
Okay. And looking ahead, what are the next steps of this experimental site?
Well, in the context of InBestSoil, in the Lighthouse 3, the next step for us is the research on the barriers and opportunities for the development of a market for technosoils in the country, because this is the main point that can help to develop the potential of this technology.
To close, if you could share one key message from this experience, what it would be?
For me, the main learning from this project is the relevance of trust and sociopolitical arrangements for the development of more sustainable practices. In this case, trust was broken when the mine was left abandoned. The mining company was irresponsible, and we can also say that public authorities failed to take charge of the situation, and they were irresponsible too. So that was a bad starting point. But we need trust to develop innovation, because the innovation for a sustainable future needs an environment of trust between social agents, because it involves changing the way things are usually done to create new rules through open alliances and collaborations. So when institutions, private or public, or even the third sector organizations focus on their immediate interest, and they lack there's a lack of impulse of innovation. And I think it applies mainly to political authorities who I believe should be leading society towards the sustainable transformation of the economy.
Well, thank you so much, Javier, for showing us that technology and biology can work hand by hand to feed the world while caring for the sphere planet. And to all our listeners, thank you for joining us. Don't miss the next episode of Soil Talks. Thank you.